Hey y'all. Today I'm going to show you two methods for solving a quadratic equation. I'm going to show you the square root method now, and then in the next video I'm going to show you how to solve the same quadratic equations, but you can solve them by graphing. You'll be able to use whichever method that you like because they give you the same answer. So let's start with this one. So we're going to solve this using the square root property. So clearly, some point in here, we're going to be taking the square root. So the first one says 5x squared minus 19 equals 231. Just is the case as with the first unit, your goal is to try to get x all by itself. We're going to have two answers because my highest exponent is 2. If my highest exponent was 4, we'd have 4 answers. If my highest exponent was 5, we'd have 5 answers. But this one, my highest exponent is 2, so we're going to have 2 answers. So let's get started. We're trying to get the x by itself, so the opposite of a minus 19 is to add 19 to both sides. So we're going to add 19 here, add 19 here. This is going to give me 5x squared equals 250. So nothing new. We're still solving the equation. Opposite of multiply by 5, this is divide both sides by 5. So this gives me x squared equals 50. The opposite of squaring something is to take the square root. So square root this side, square root this side. X equals plus or minus the square root of 50. Now we do plus or minus because if I, let's do a simple example. If I ask you to give me the square root of 25, so if I ask you to give me the square root of 25, 5 times 5 is 25. And negative 5 times negative 5 is 25. So we take the positive and the negative because two positives can give you a positive when you're multiplying, and so can two negatives. So that is the purpose of us putting this plus and minus sign in the front. Now, this is not truly simplified. I do need to do a factor tree and break this all the way down so that it's truly, truly simplified. So I'm going to do that off to the side. So I got 50 here. I'm going to do a good old-fashioned factor tree. 50 is 10 and 5. 10 is 5 and 2. So I broke it all the way down to prime numbers. You're looking for pairs of the same number. So this gives me 5 square root 2. So in simplified form, this plus or minus square root of 50, x equals plus or minus. I want to put it in simplified form. So this is my final answer. And as a decimal, I already stuck that in the calculator. It gave me the following. Okay, so this is our answer. So let's do a little recap before we move on to the next problem. So this is my problem up here at top. 5x squared minus 19 equals 231. The first few steps, we were just solving the equation. Opposite of a minus, you add it. Opposite of multiplying, you divide. You got to get the square root part by itself first. So when I got the square root part of the problem by itself first, I took the square root because the opposite of squaring and square rooting is the opposite of squaring, is to take the square root. Then we did the plus or minus. This over here to the side, we were breaking our square root down because it needs to be simplified. So we do a factor tree. If you have 2 of the same number, that number goes on the outside. The leftover number goes on the inside. So my exact answer, which is what I would prefer you to type in unless otherwise specified, x equals plus or minus 5 square roots of 2. And as a decimal, it's approximately plus or minus 7.07. So 7 and 700ths. So that was the first one. All right. I will do a few more just to make sure we have lots of practice. For the most part, you're just solving an equation. Except for when you get down to square, you'll need to take the square root. I am going to erase this little factor tree here so I can get to the other problem. But you're watching a video, so you can just pause as you see fit. Let's do number 2. Now, if you look at number 2, it's a little different than the first one. The first one had the x squared already by itself. This is in the parentheses, so we cannot take the square root just yet. Instead, I need to go ahead and divide both sides by 9. This is multiplying by 9. We need to divide by 9. So I'm going to divide this by 9, and I'm going to divide this by 9. So those are going to cancel out, and it will give me x minus 2 squared equals 121 over 9. So yes, that is a fraction. Yes, it looks kind of messy, but that's okay. So 9, opposite of multiplying by 9, we divide it by 9. And then I do have an improper fraction, but that's all right. There's nothing wrong with that. So I have this 2 that's here. We're going to take the square root of both sides. So I'm going to take the square root of this side, and I'm going to take the square root of this side. So squaring and square rooting cancel. So I have x minus 2 equals plus or minus. Now, lucky us, these are both perfect square numbers. 11 times 11 is 121. 3 times 3 is 9. So lucky us, these are perfect square numbers. But if you didn't know that, you would stick this in the calculator, and it would tell you that this is 11 over 3. So again, the square root of 121 over 9. You can type that in Desmos or in a calculator. It'll give you 11 thirds. Both of these are square root, perfect square numbers. So if I take the square root of 121, it gives me 11. If I take the square root of 9, it gives me 3. So both of these are perfect square numbers. So far I have x minus 2 equals plus or minus 11 thirds. And I got one more step. We're trying to get x by itself. So I need to add 2 to both sides. So x equals 2 plus or minus 11 thirds. So I put the 2 in the front instead of having it right here with the fraction. I just put the 2 in the front. In just a minute, I am going to separate it and get my 2 answers. So 2 plus or minus 11 thirds. 2 plus or minus 11 thirds. This plus or minus tells me that I'm going to get 2 different answers. So we're going to do 2 plus 11 thirds and 2 minus 11 thirds. So I want to make sure we're straight there. We did 2 plus 11 thirds and then 2 minus 11 thirds. And we can use our calculator, do it in our head, whatever the case may be. So my final answer, we should get 17 thirds and negative 5 thirds. So 17 thirds, negative 5 thirds. Okay, and we took this. There we go. So, recap. The problem is in the red. The opposite of multiplying by 9, we divided both sides by 9. That was nothing new, nothing to do with quadratics. The opposite of squaring something is to take the square root. I can put this in the calculator or do some mental math because they are perfect square numbers, but whatever method you take is going to give you 11 thirds. After you get 11 thirds, the opposite of subtracting 2 is to add 2 to both sides. Now, from this step, you could leave it like this. There's nothing wrong with that, 2 plus or minus 11 thirds. But since they're both numbers that we're working with, let's get our final answer. So 2 plus 11 thirds and 2 minus 11 thirds. And then either get a common denominator or stick it in your calculator and get your final answer. All right, I would like to do one more problem. So square root method. Okay. So let's do 4 s squared plus 7 minus 9 equals 30. All right, so let's go through and solve this problem. We're gonna add 9. We need to get the s squared by itself first. So we need to add 9 to both sides, and we need to divide by 4. So we need to add 9 to both sides. And the opposite of multiply by 4, we need to divide by 4. So first 2 steps that we did, we need to get this s squared by itself. So I added 9 to both sides. And then the opposite of multiply by 4, we divided by 4. And 48 divided by 4 gave us 12. All right, I need to keep going because we need to get s squared by itself. So we're going to subtract 7 from both sides. So s squared equals 5. The opposite of squaring something is to take the square root. So s equals plus or minus the square root of 5. 5 cannot be broken down like the first example we did, so there's nothing wrong with that. And my final answer is plus or minus the square root of 5. So this is the square root property. In the next video, I'll show you how to get the answers by doing the graphing method, which you might find a little easier.